and welcome to the video on covalent molecules, specifically naming them and writing their formulas. So let's provide a little bit of context. First, where we've come from. We've looked at elements, mixtures, and lastly, focusing on ionic compounds. Ionic compounds, if you recall, are combining a metal with a nonmetal, say magnesium with nitrogen. And those two come together and form a bond, an ionic bond, by gaining and losing electrons. So both of them reach octet status. And we have some naming rules and formula rules that we'll have to follow for those. Today, we're going to introduce molecules that form, bonds that form between just two nonmetals. Those are covalent molecules. Now, nonmetals behave when you form a bond between two molecules, two nonmetal atoms, the electrons can't be swapped. They do things a little bit different. They have to share those electrons, but the end goal is the same. Both atoms, or however many atoms in that molecule, do this so that they can all reach octet status. Now, when we write formulas for covalent molecules, and when we write their names, their conventions, the rules that we follow are a little bit different, and that's what this video will talk about. Now let me advance the slide, and here we go. Or not. Here we go. All right, so our focus really is just going to be naming those covalent molecules and writing their formulas. We're not going to focus too much on how that bond forms. So let's get down to business. We'll start with naming. Naming covalent molecules. First off the bat, you have to be dealing with two nonmetals bonded together. They do this by sharing electrons. When we name covalent molecules, we'll utilize prefixes to indicate quantities of each element. Prefixes are written at the beginning of the element name. These can be found on the back of your periodic table in the third column. Notice we will not be dealing with the first two columns on the back of our periodic table. Those are for ionic compounds. So if you flip over your periodic table, you'll see a little box that has the prefixes you need for naming covalent molecules. They look like this. Now there's a couple more rules I want to go through before we do an example. The next rule is now we're dealing with two nonmetals, so we have to distinguish which one do we write first in the name. In this case, the one that's farther left on the periodic table will get written first. The second nonmetal, you'll see a familiar suffix here. The second nonmetal, that element name gets changed out and added on that IDE suffix that we found in ionic compounds. So that is some familiarity. Let's try an example. I'm just going to move myself up here. All right. We have our first example of a covalent molecule. We have hydrogen and boron. I'm going to write it down here using this kind of template. So first we start with the amount of this particular atom of hydrogen. There are 6 of them. So I'm going to look up that prefix on my periodic table, and 6 prefix is hexa. Then I'm going to write the full name. We have hydrogen, and now we're on to our next element, which is boron. First, we utilize the prefix di because there are 2 atoms of boron, and then we simply write the element, but we can't write boron. We change the name to boride. So if I were to write this out in 2 words, the first name, if you will, of the covalent molecule is hexahydrogen, and the last name is diboride. There you go. That's it. Naming covalent molecules. Let's go the other way around if we were to write the formulas for these covalent molecules. So let me give you the rules first. Just like before, the nonmetal farther left will be written first in the formula. The prefixes in the name will tell you the quantities of each element to use, And if you recall, amounts of any type of element are always written as those lower letters, or excuse me, numbers, known as subscripts. And finally, if you don't have a prefix in a name, you can assume that there is just one of those types of atoms. Let's do an example. Here we have carbon dioxide. We all heard of it before. Let's write its formula. So there's no prefix out in front of carbon. So I'm just going to do the symbol for carbon, and you can write the 1. It's assumed since there's no prefix, it's just 1 carbon. Then I look at the second word and I notice that the element oxygen here, remember the "ide" is a little different, so I'm just going to use the symbol O, and the prefix di, meaning 2. So if I were to rewrite this, carbon dioxide, as you guys know, is CO2. So now you can see the meaning behind the name and the formula. Now I'd like you to take a moment to pause the video and try your hand at 3 of each, writing 3 formulas and writing 3 names. So go ahead and pause the video and we'll come back and we'll see how well you did. All right, we are back. The first one. So when I write covalent molecules as their formula, I like to start off with just the element symbols. So we have hydrogen and oxygen. So I put my H, I leave a little gap for a potential subscript, and there's my oxygen. Now I go back and look at the prefixes. Here we have di. That's 2. And here's a prefix for mono, meaning 1. If I rewrite this as an official chemist, ladies and gentlemen, friends, you have the official name of water. H2O is dihydrogen monoxide. Impress your friends. Next one up, 2 elements, 2 nonmetals, nitrogen and bromine. We have N, and bromine is big B, little r. And now I look to the prefixes. There's no prefix, so I assume that there is a 1 after that N, and tri is 3. So as a true chemist, nitrogen tribromide is NBr little 3. Last one for our formulas, we have sulfur and hexafluoride. That's the element fluorine with its just suffix on the end. There is no prefix in front of sulfur, but there is a prefix for fluoride. Hexa means 6, SF6. Now let's go the opposite way. We're given the formula, we have to write the name. So here I'm looking at my 2 elements, my 2 nonmetals, hydrogen and iodine. There are no numbers as subscripts, so there's really just 1 atom of each in this covalent molecule. So I'm going to start off, again, remember there's no prefix out front if there's just 1. So I'm going to start with the full name, hydrogen. We don't change the ending on the first element. Now here is perhaps the trickiest convention for these non-metal covalent molecules. There's 1 iodine. So just like hydrogen, we would write iodine and change the ending to IDE, iodide. However, if there is a 1 single atom and it's the second element listed, that's when you use the prefix mono. So monoiodide. For some reason, chemists leave off that mono if it's listed, if it's for that first element. If it's for the second element or any other elements down the line, mono is when you do utilize mono. So that's a weird one to get used to, why it isn't monohydrogen, monoiodide. So when mono is for that first one, you drop it. You only add it to the second elements. Moving on, we have a phosphorus and an oxygen. Remember, if you don't know the names of those elements, look up the symbols on the front of your periodic table. So here we have prefix, there's 2 phosphoruses, so we have diphosphorus, that's a long one, and 5 is our prefix, meaning pentaoxide, diphosphorus pentoxide. And our final one has 2 nitrogens and 3 sulfurs, dinitrogen trisulfide. Ide, 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 ide. So that's a look at naming covalent molecules. And I really hope that was helpful. Remember, utilize those prefixes written on the back of your periodic table to help you name these and write their formulas. Now let me just show you the big picture here before we close out. Here are the critical differences between the two types of formulas and in naming that we will be doing. So we did ionic compounds, that's between a metal and a nonmetal. There is an IDE suffix, but remember with those big atoms like nitrate, they can have different endings, or nitrite, or just if it's a single nitrogen, it's nitride. So they can be a little bit tricky in that regard. And then you also have to remember if you're dealing with a transition metal, something like cobalt or chromium or iron, which can have multiple charges as an ion, and so you have to designate what Roman numeral, what ion you are working with for that particular compound. Covalent molecules are a lot simpler. You don't have to worry about charges equaling to 0. All you have to worry about is utilizing those prefixes appropriately, getting that suffix on the very last nonmetal listed in that molecule, and just make sure you're dealing with 2 nonmetals, because the rules are different if you have a metal mixed in. So thanks for listening, and now it's your turn to get practicing.